Let's take a look at the mole ratios for the equation H2 plus O2 gives us H2O. We have hydrogen gas plus oxygen gas, and we get water, and that would probably be a gas as well, since this is exothermic. So for the mole ratio, the first thing we have to do when we're dealing with mole ratios, we have to balance the equation. So let's do that. I can see there's 2 oxygens here and just 1 over here in the water. So let's put a 2 in front of the H2O. Oxygens are balanced, but 2 times 2, 4 hydrogens. If we put a 2 here, that's the balanced equation. And although we don't write it, there's a 1 in front of the O2. And these coefficients here, that's where we get our mole ratio from. We have a 2 to 1 to 2 mole ratio. And you could write that like this. So we could say for every 2 moles of hydrogen, we have 1 mole of oxygen in this reaction. Or for every 1 mole of oxygen, we have 2 moles of water. Finally, you could say for every 2 moles of hydrogen, you have 2 moles of water. And it doesn't have to be 2, 1, 2. It can be any number as long as the ratio breaks down to 2, 1, 2. Let's look at the mole ratio for oxygen and water. So for oxygen and water, we have 1 mole of oxygen for every 2 moles of water. This is really useful when we're doing reaction stoichiometry. We're often given one amount and then asked to figure out how much we'll get of the other amount in the reaction. So we can use mole ratios to figure that out. For example, pause and think about this. What if I had 23 moles of oxygen? How many moles of water would I have? So 1 to 2, we've doubled this. We have twice as much water, so we'll just double this number, 46 moles of water. What this means is if I started with 23 moles of oxygen and I had excess hydrogen here, I would end up with 46 moles of water, and that's why it's so useful. One last thing. As you go on in chemistry, you'll use the mole ratio to solve stoichiometry problems. There's links in the description if you need help with that. But when we do that, we often write the mole ratio as a conversion factor, and that'll look like this. We have 1 mole of oxygen for every 2 moles of water. We could also write the reverse. Often when teachers say mole ratios, this is what they're talking about, these conversion factors. But many times you can reason these problems out just by thinking of it this way. There's a link in the description for practice and explanation about how to use these conversion factors as mole ratios. This is Dr. B with the mole ratio for H2 plus O2 gives us H2O. Thanks for watching.